Hello, I'm Norihiro Yoshida from Nagoya University, Japan. I'll talk about an approach for extracting a micro-state transition table using the KLEE Symbolic Execution Engine. First of all, I'll talk about legacy code in embedded system development. In embedded system development, specification documents are often outdated because ad hoc code modification is often performed when deadlines are approaching. For example, condition branches are frequently modified and it causes the change of specifications. On the other hand, practitioners in embedded system development need to address hardware variations. To address the hardware variations, they frequently use source code from similar products. With this background, practitioners want to use code, but an automated document is barrier for them. We discussed these issues with our collaborators in industry. They said practitioners need an automated tool for extracting a state transition table from C module statically. According to their opinions, firstly, static analysis is more desirable for them because it is sometimes hard to prepare a runtime environment of the embedded system. Secondly, they also said practitioners can give a state variable, so the tools do not have to identify a state variable automatically. Thirdly, they use a micro-state transition table for the development, so they want to extract a Msdd automatically. Let me explain about Msdd. Msdd is state transition table at module level. For example, at compilation unit level. In Msdd, states are a set of values of a user-specified state variable, and events are a combination of values of the other variables. The table on the slide is an example of Msdd. In this Msdd, variable st is specified as a state variable by a user, and states are st equals 1, st equals 2, and st equals other variables. First event is t equals 1 and s is smaller than 10. Second event is t equals 1 and s is equals to or greater than 10. Third event is t is not equal to 1. Processes and transitions are written in the cell corresponding to a state and an event. Practitioners need an automated tool for extracting an Msdd. In other words, they need an automated tool for specification inference. This is because it is unrealistic to extract an Msdd manually from a module in C source code. One of the reasons is C modules sometimes includes complex condition branches. Another reason is human resources for the embedded system development is very limited, so they need an automated tool. In this study, we develop an automated tool for extracting an Msdd using KLEE. The proposed tool generates a symbolic execution tree using KLEE. For this purpose, KLEE is one of the best tools because KLEE can analyze directives, pointers, and arrays correctly. Figure on the slides illustrates an overview of the proposed tool. Firstly, the proposed tool runs KLEE to generate symbolic execution tree and the corresponding instruction sequences. It transforms them into an extended symbolic execution tree. After that, it makes condition process table from the extended symbolic execution tree, and finally it extracts an Msdd from condition process table. Hereafter, let me explain the detail of each step. In step 1, the proposed tool dumps a symbolic execution tree, and the corresponding instruction sequence, as you can see on the slide. Each node represents a statement with a line number and edge represents a condition branch. Instruction sequence is made by the depth-first search, so it is depth-first sequence of symbolically executed instructions. In step 2, the proposed tool adds the corresponding line number to each edge of symbolic execution tree. In other words, it transforms symbolic execution tree and corresponding execution sequences into an extended symbolic execution tree. Here on the right-hand side is an example of extended symbolic execution tree. In this tree, edge has line numbers of statements as labels. Now each path of this tree includes line number and statements and condition when the path is executed. In step 3, the proposed tool extracts the pairs of condition and the corresponding process from an extended symbolic execution tree and make a condition process table. Figure on the right-hand side shows an example of a condition process table. This table shows pairs of condition and corresponding process. In step 4, the proposed tool extracts an Msdd from a condition process table based on a user-specified state variables. Figure on the slide shows an example of Msdd. In this Msdd, variable state is specified as a state variable and other variables are used for event triggers. As a summary, we propose an automated tool for extracting Msdd from C source code using KLEE. As future work, we plan to perform a larger case study because we just applied the proposed tool to a small-scale industrial source code. Also, we are interested in floating point numbers version of KLEE. We would like to use it for extracting Msdd. Thank you.